So at the top of page 44, you can see it starts the list of sample test problems. And I think I'd mentioned generally on the review day, we would just go over as many of these as possible. We're going to try something different. I've made a video of me solving any one of these things. It was quite time consuming to do this. So like I said, I'm hoping that folks get something out of it. So two things that you have access to now. Number one, back in our Moodle page, you'll see there's a PDF for problems from sample test 1. It's those same problems, but I will open the PDF filled in with all of the stuff that I've done in color, highlighters, all that jazz, okay? So you have that, that's on Moodle. In terms of the videos, let me just play briefly part of the video of me solving this first problem. So this is the kind of thing that you will have access to if you just type in the right URL, okay? So it's me going through in detail every one of those sample test problems. I know that some folks are having issues watching the videos. In particular, we haven't found a solution yet for Mac users. If you are a Mac user and you find a solution, please let me know so I can share it. I did contact one of my colleagues here, and he said that there's this free software called Flip for Mac, which you will, if you Google it, you can find it on the Microsoft site. There's a direct link if you want it, but easiest thing is just to Google Flip for Mac. And download it. And two people that work here in the IT department have told me that this will work. Now I have one student in this room who tried this already and it didn't work, so I'm hoping that we have some successes and maybe this is just a localized problem, but try this if you have a Mac and you haven't been able to watch the videos, and please do let me know if it works. Another thing that I'm working on, because like I said, I think the videos are a good resource for some folks. I'm thinking about posting these things on YouTube. Now, YouTube is great in that it gets rid of all the technical issues, right? You just watch it on YouTube and we've got no problems. I do need to check with our legal department and make sure that it's okay for me to put our stuff up on YouTube. But I'm working on that, and I'm hoping that today I have some positive sense that I can go ahead and go through with this. So if things end up on YouTube, I will send you an email to your GCC account as soon as I've got information telling you that it's up and telling you how to get it, right? So I'm hoping that that will be a solution to all of our problems. In the meantime, though, there's still if you have found success doing it, you know, the URL way, then that's great. One thing, somebody had been typing this as medial, M-E-D-I-A-L. That is a 1, but it looks an awful lot like an L. So it is medio 1. So if you've been typing the wrong address, it's definitely not going to work. And if you have, just try this address with a 1 in it, and maybe that'll fix everything. Don't know. Any questions or comments on the video stuff? Okay, so we got that, and. Okay, I think that's everything I wanted to share. Oh, one other thing. If the whole, that's not where I want to be. If the whole downloading stuff doesn't work for you for whatever reason, you should know that all of these videos and PDFs exist on this computer. And so if you have a flash drive and you bring it in, you can plop it in the computer. I need to be logged in to have access to it. But when I'm here, you can just grab all the stuff, and then maybe that gets rid of the whole internet part. And then you just have the raw videos and the PDFs, and maybe there's no more problems. I don't know. But anyway, they exist here on this computer. So anytime I'm around, just let me know, and we can try it that way too. All right, resources. I mentioned to you these problems here on page 44, lots of sample test problems. And if you go down, you will find an answer key. So if you get rid of all the technical issues, at least you just have the straight answers. If you want those, you can check your work. And then I will show you something else that, that I just put in this semester that I don't have an answer key for. And these are problems starting on page 48. So in the middle of page 48, you see it says even more sample test problems. And I got these from someone who taught this class 1 year ago in the evening, and so her name is Kelly, so thank you to Kelly. But she didn't have an answer key, and I have enough stuff to do without doing more pre-calc practice problems. So I will say, though, that if you try these problems and you have an answer key that you're willing to share, then I'd be thrilled to photocopy it for everybody else in the room, okay? All right, so that is that. Let's go to the new stuff for the day, which is on page 53. And we'll go to number 1 at the top of page 53. And can we go to Kyle, number 1? So if you've got a good memory, you'll recall that we actually did talk about those two topics in part of one class. So we're going to go a little bit more detailed today, and we'll see some different problems that we didn't answer the first time we mentioned these two ideas. We'll go to number 2 for Sarah. Okay, so we've got to try to get our hands on these two functions. So first the R function. What's the input for the R function? Corn yield per acre. So like how many bushels of corn the farmer gets per acre certainly has a strong impact on how much revenue they end up getting, right? And then what's the input for Y? Is the amount of fertilizer, and presumably if you put in a lot of fertilizer, you will get an improved corn yield, although maybe there's some point where you've got too much, I don't want to say it, in the yard, and then the corn yield goes down again. So what does R of Y of Q represent? Okay, ultimately what's the input? Is the amount of fertilizer. So given the amount of fertilizer, we then kind of temporarily go someplace. What is Y of Q? What's the output of that thing? Yeah, that's the corn yield per acre. And then ultimately, what's the output for the R function is the revenue. And so one thing you guys remember about composition of functions is that you start with the inside and you work your way outside. And really, if I'm just talking about that massive composition, I'm just going to kind of put a line through the middle thing. It's a temporary stop, but it's not really part of the input or output for the whole function. So this massive function, that R of Y of Q, given an amount of fertilizer, outputs how much revenue this farmer can expect. Questions on that? Okay, so we're going to skip around a little bit here because the quiz is kind of long, and I want to make sure there's enough time for you guys to do the group activity at the end. I'll just mention here on number 4, I've got two functions. We've already done examples that I was going to do here, like figure out what f of g of t is and what g of f of x is. It's just a matter of putting the right thing into the right spot. We're going to skip that. Let's come down here to number 5, and we'll go to Vance. Okay, can you guys try that? Looking at the information from the table and checking with your neighbors. Okay, so for the first one, we need to do f of 2. How much is it from the table? 0. Oops. And then we need to do g of 0. How much is g of 0? 6. Super. Go in the other direction. We first need to find g of 0. What is it? It's still 6. And according to the table, what is f of 0? Sorry, f of 6 is undefined. Okay, fair enough. So it's quite possible that you get somewhere that you're not allowed to be by doing composition of two functions. Todd? Yes, it is. Today is the last day of new stuff for the test. And again, in terms of material for the test, it's everything on the calendar up above this line that says test 1, but also it's this entire packet. That's sort of the goal of how I've organized it. Is everything in that packet is the test, and the day we come back after the test, I will give you another packet, which will be the second test material. Okay, try number 6 here. We'll go to Hillary. Okay, let's try those two things. Same idea as the table, but now you're trying to read the information off the graph. So check in with each other on that one. All right, how are we doing on this one? How much is f of 4? F of 4 is 2. Everybody's okay with that? That's this point right here. F of 4 is 2. And then how much is g of 2? G of 2 is up here at the top as 5. So what that means is that we've got a new point on this g of f function. Apparently, when I put in what input for g of f, what was the input we just did for this? The input was 4. And then we ended up going to 2, but that was just the kind of temporary place in the middle. Ultimately, we end up at 5. So there's this new function, which is not graphed up here, called g of f, where if you input 4, you get the point 5. So 4 comma 5 is on the graph of this other function that doesn't live up here yet. And then the same kind of idea, we could do g of f of 5. How much is f of 5? F of 5, f of 5 is 1. Okay, so then how much is g of 1? G of 1 is up there, that's 4. So then same kind of idea. What was the original input? 5, and then the ultimate output is 4. And so you can begin to sketch the graph of the composition of two functions by plotting points. 4 comma 5 is on there. It's up here. 5 comma 4 is on there. And it's really quite challenging. It might be a good exercise to like try to draw the graph of f of g given, or I guess we're doing g of f, given, you know, the graphs of f and g. It is definitely not something that I can just say, oh, okay, yeah, sure. I look at those two, and then this guy goes that, and then it goes over here. Like, I am quite confident that is not right, and I don't have any shortcut. I would literally have to plot enough points until I felt comfortable that I had like the shape of the graph. It's very challenging to graph the composition of two functions given the pictures of the two functions. But that's a way to do it, is to plot points. Any questions on that? Okay. Next page, number 7. And Hillary, did you read? Yes, you did. Bryce.
Often we will want to decompose a function as a composition of 2 or more functions. This will be very useful in calculus. Doing this, think about the order of operations. Use the thing first as the inside.
Okay, we'll go to Garrett for the next part. Okay, so let's look at part A. So we've got this function e to the 2x plus 1. And I want to think of that as being the composition of two simpler functions. So what happens first in this case? Is it the e or is it 2x plus 1 if you're like actually plugging in a number for x? 2x plus 1, right? If I just said plug in 7, the first thing you would do is 2 times 7 plus 1. So it feels like that's the first thing we do. And does the first thing you do go outside or inside? Inside, because when you compose functions, you look inside to decide what to do first. So it seems to me that 2x plus 1 is a natural choice for the inside function. And then this is the part that a lot of folks find tricky. The outside function is the thing which is just e to the whatever you've already found. So the formula is just e to the x. It's e to whatever you already calculated. And if you don't buy it just yet, then figure out what f of g of x is. What would we do? Let's see. F of, what's g of x? 2x plus 1. And then f is a function which takes whatever you give it and sticks it on top of the e. So whatever we give it, oopsies, whatever we give it, we stick it on top of the e. So we gave it a 2x plus 1, and that goes on top of e. So it's really easy to miss that outside function. But it doesn't have anything to do with the 2x plus 1. It's just the e function. Can you guys try part B? Find two functions and check with your neighbors. Okay, so what's the inside function, the thing we do first? It's 3 ln x plus 2. That's the first thing you would do. Then you would take the square root last. And the first thing you do is the inside function, which we're calling g in this case. And once you know what the inside function is, what's left to do on the outside is take a square root of it, which is square root of x. Yeah, Chris. Mm-hmm. Okay, so you're trying to break it down. This function break it down into 3 functions. Okay, let's try that. Okay, so f. How are we writing this? F of g of, I can't use h. Let's use j of x. And we're trying to make that thing equal to this. So Chris has the following suggestion. You said f of x was the square root function, and g of x was x plus 2. And then j of x is 3 ln x. Can you guys check with your neighbors and check with each other about whether or not that's right? There's a lot of support for your functions here, Chris. This is looking good for you. Yeah, this is perfect. I mean, like this is a way to break a function down into 3 functions. It's quite a natural way to do it. What about x plus 2? Okay. So you would like it to be that to match up with this. Okay, so let's think about the remove. Yeah, the natives are not happy with that test today. So if we're thinking of this, just look at this part right here, g of j of x. So we take our j of x, which is this 3 ln of x, and we stick it in here, into the g function. So we're going to take this thing and we're going to stick it into the g function, which means we're going to stick it in for the x. And so when we stick it into the x, that x becomes 3 ln x, and then separately is a plus 2, which I think is what we're after. Yeah. It's the outside functions. The inside ones we have no problem with, but the outside ones are quite tricky for a lot of folks. Yeah, I think that's good. Very nice, Chris. Yes, so it turns out there's a lot of different ways to decompose. So Chris invented a third one, but Todd, what did you have? G of x is the natural log of x. Okay, 2 functions. Again, trying to get it to look like that. Can you guys see if you believe that f of g of x for Todd's functions works? It works. So it turns out there are a lot of different ways you could decompose our function into simpler functions. One thing, if I ask you a question on the test where I say do this kind of thing, I might put something like, find 2 functions where neither function is just f of x equals x, where neither function is that. Because that function takes the input and gives you exactly the same output, right? So you could answer every one of these questions and not really do anything. You could say that f is just going to give you what you had, and g is going to do all the work. And that works. Poor g, right? We need to distribute the labor a little more equitably. It does work. But we haven't really accomplished anything by doing that. So I'm going to insist that we don't do that. Okay, good. Thank you, Todd. Thank you, Chris. No, we've got some labor laws we're trying to satisfy here. Okay. All right. Again, in the spirit of saving some time, we're going to skip past some stuff here. If you see the symbols f plus g, it means take the 2 functions and add them up. We've seen it before. Try it later. Inverse functions are functions that undo each other. This is the second topic, with composition and inverse functions. So for example, x cubed plus 1 compared to the cube root of x minus 1. Turns out those functions exactly undo each other. There's the intuitive way of thinking of things. Let's look at this cube root of x minus 1. What does it do first? If you were to plug in a number for x, you would first subtract 1. So first, we subtract 1, and then second, take the cube root. That's what the g function does in that order. So if I would like to undo that, not only do I need to do the opposite of these things, but what else do I need to do? I need to reverse the order as well. It's similar to this morning, you put on your socks and then you put on your shoes, right? When you go home, you need to undo those things, but you better not take off your socks first and then take off your shoes. It doesn't work so well. You got to undo them in the reverse order. It would be a challenge. So if we wanted to undo these things with an inverse function, we go the reverse order. What's the opposite of taking the cube root of something? It's the cube. And then the opposite of subtracting 1 is add 1. And so if I were thinking of this in terms of symbols, I would say, okay, I take my x, I cube it, and then I add 1. And that's exactly what that function is. So that's kind of the intuitive way to take a relatively simple function and figure out how to undo it. So still, let's move this up just a little bit. Still skipping some stuff. We're going to go to the next page. Maybe there's a picture that you can kind of see where it's already headed. You've got some function and the line y equals x, and there's a symmetry thing happening between a function and its inverse. You can have a look at that, but I think we mentioned it. I also think we've mentioned this list of facts about inverses. Come back to that. You can take a look at that later. But I just want to do one more thing before you guys do the group activity, and that's to find the inverse of a function. Now, we kind of did this already today, just a minute ago, when we had this function. Was it that? It was that. We had that function, and we figured out the inverse function. Now, that function was relatively straightforward, and we could kind of do it intuitively. But to figure out the inverse function of this thing, that's quite challenging, to just do it intuitively. This is a function which takes whatever you give it, x, doubles it and subtracts 1. On the bottom, it adds 3 to it, and then it divides those two separate things. And how to undo those, I couldn't tell you. I mean, I can't make a list of first it does this, then it does this, then it does this, and now let's just go the other way. So we'll do the process, and I think we've seen the process before. The first step maybe is to, instead of calling it f of x, we'll call it y. And then what do we do with the x's and y's? Swap them. And now we're trying to solve for y. And oftentimes this is easier said than done. This is the hard part, solving for y. But I put a relatively tough one here, just so like if you can do the toughest one I throw at you, then you should be able to do all of them. So what I'm going to do is cross multiply. So I get x times y plus 3 equals 2y minus 1. And the idea is to solve for y, and the difficulty is that there's y's in two different places. And at the moment, one of those y's is buried inside of parentheses. So our first motivation is to get rid of those parentheses so we can really get our hands on the y. So we'll distribute. And now the two y's are at least accessible, but they're on different sides of the equation. So what we're going to do is move all the y's to, say, the left-hand side, and everything else without a y to the right-hand side. So when we bring the y's over, what does it become? Minus 2y. And then we'll bring everything without a y to the other side. So negative 1 minus 3x. Okay, so can you guys give me a sense? I have people in the back of the room craning their necks. So can you give me a sense, what's the lowest thing you can comfortably see? Okay, so pretty much your line is right around there. Thank you. And now that the y's are on the one side, what can you do to the left-hand side? You can factor out a y. So x minus 2 goes in those parentheses. And I know it's just this whole big procedural thing, and we did a bunch of stuff that it wasn't really clear why we were doing all that stuff. This is the one moment that kind of directed us the whole time. How many y's were in every equation up above? 2. This is how you make it so there's a single y, so that you can solve for it. Can't deal with 2 y's. So what do? We move all the y's to one side, and then everything without a y to the other side for this moment right here, where you can factor out the y, because everybody over here has y, and everybody on the other side doesn't. And then finally, to solve for y, divide. -1 minus 3x over x minus 2. And that's our answer. Maybe we'll call it f inverse of x. Questions on that process to find the inverse of a function? Todd? Okay, let's take a look at Todd's answer. You said 3x plus 1. Okay, this is Todd's answer. Is Todd's answer right or wrong? One vote for right. Looks different to me. Another vote for right. Todd, there's support is building. Yeah. If you factor -1 out of the top and the bottom, or if you prefer, multiply the top and the bottom by -1, which is allowed, as long as you do the same thing to the top and the bottom, and we get exactly what Todd said. So, all good. Any other questions about finding the inverse of a function? Okay, so we have a little over 15 minutes. The group activity is right there. And it goes on to the next page, and there are answers that eventually follow. See how far you can get.